Hello. Hello. Good. Good. So please, in ray diagrams, when you are doing it, when you are drawing rays, do it with straight lines or with a straight edge, because I have to maximize time. That's why I'm using freehand. But when you are doing it, use straight lines or straight edges. Are we fine?
Yes, please.
Oh, so because the surface is well polished, we have every single incident ray or light being reflected. So we have incident beam, and then we have reflected beam, and this is what we call as regular reflection.
Please, what have you written at the
Where
left side?
this is incident beam,
Okay.
and then this is reflected beam. Then what about irregular? So regular or specular reflection occurs, okay, when you have well polished surfaces or smooth surfaces, and then incident beam, okay, we have incident beam because the surface is well polished and so smooth. Every beam with incidence gets reflected. An advantage of regular reflection is that this brings about formation of images. Regular reflection of light brings about formation of image. So if this is a very smooth surface and you have the sun here, rays coming from the sun, when they hit on the surface of a well polished material, you easily capture the image of the sun on the, okay, behind this as the image. So it hits, the rays hit, it gets reflected, and you could trace the image of the sun below. Because I have a diagram here. So when you are walking, you see the image of the sun within the medium, the second boundary as the image, which is a virtual image within the image. So regular reflection, okay, brings about formation of images or image. Now, irregular reflection. Irregular reflection, on the other hand, occurs on rough surfaces. So when you have a rough surface, not smooth or not well polished, rough surface, and you have a beam of light in a pattern incidenting on the surface regularly or orderly. So what is hitting on the surface is of some orderliness, but because the surface is rough, so here we have incident beam. that are orderly. Because the surface is rough, the reflected rays or beam are scattered. So here, the difference is that the incident beam which came without orderliness or orderly gets reflected, but the reflection is scattered. It is not in that orderliness as we have in regular reflection, but here it is scattered. And it is scattered because of the nature of the surface. Are we fine?
Yes.
So, any reflection which occurs on, on walls, you see, because most walls are not well polished, rough. Look at the nature of the sand, very rough. Reflection which occurs on walls. Reflection which occurs on the surface of the earth, is a classical example of irregular reflection because the surface of the earth isn't even. Some of the incident rays are hitting on you and I. We have different nature of dresses or clothes we wear. Somebody is wearing khaki, jeans, whatever. So the nature of the surface would give it that kind of reflection. But here we need to have smooth surfaces for regular reflection to occur. Here, so long as we have a rough surface, we are good to go. The disadvantage of this kind of reflection is that no image formation can occur. No image formation can occur because for formation of images, we need two or more rays to intersect at a point or appear to intersect. But because of the disorderliness of the reflected rays, no image can be formed in diffuse or irregular reflection. Please, are you okay?
Yes, please. Sir, please. I have a question, please. The regular reflection, is it like by all means that an image must be formed on the surface that it reflects on?
Yes, because the reflected rays are in order. So we'll have a situation where the reflected rays may converge at a point or may appear to have converged at a point.
Okay, Mr. Adria,
Hello.
please. So like if the object is opaque and let's say red and it's smooth, this one, no image is formed on the surface, but is it still regular reflection?
If
is it even reflected in the first place? Like if the object or the surface is opaque, red and smooth, is it reflection at all? If it is, and is it regular reflection or irregular reflection?
Mirabel, if the surface is opaque, and the surface is smooth, let's look at let's use the road for instance. The road on which you and I travel is opaque, but so long as the surface can be so smooth, regular reflection can occur. That is why the phenomenon of mirage occurs on smooth surfaces of the road or of roads. Do you know what a mirage is?
Yes, please.
You see, when you are moving or traveling on a road in a hot, scorching afternoon, as you move along the road, you always see ahead of you as if there is a pool of water. Okay, that is a mirage. That's a mirage. And what you see is the image of the sun. Okay, but mirages can only occur when the surface of the road is smooth. Even though the road is opaque, but we have image formation, virtual image formation. Are you fine?
Yes, please.
All right. Any more questions? Akovala and Sanam. Anita. Any more questions? So
No, please.
the disadvantage of diffuse or irregular reflection is that no image will be formed. No image, being it virtual or real image, but it has some advantages. At least we can talk about a very important advantage of irregular reflection. And that is, irregular reflection brings about evenly distribution of the light or the light energy from the sun. It brings about even distribution of the light energy from the sun. Let's go to the board for this clarification.
That's for regular reflection, right?
Yeah, this is for irregular reflection.
I know. I mean the distribution of the sun, the even distribution.
I'm saying that irregular reflection brings about evenly distribution of the light from the sun.
Okay, thank you.
Irregular reflection. This is the reason. Akofala, are you there? Look at this surface being smooth. Incident light from the sun hits the well-polished surface, and they are all reflected orderly. So if we have another one here, yes, it will come. If we have another one here, yes, it will come. What it means is that per this situation, you can only have light, or you can be illuminated. You will receive brightness when you are over here. Either when you are here within the path, or when you are within the reflected path. Okay. Now, if you are not within the path of the incident and then the reflected beam, it means you cannot receive light. But somebody can be sitting under a tree, can be sitting under his or her garage, okay, or anywhere, meaning in such position you cannot directly be within the path of either the incident or the reflected. So with regular reflection, all that we are saying is that if you are not within the path of the light, you will not experience illumination or brightness of light at wherever you are. Let's come to irregular reflection. With irregular reflection, because the incident beam comes in that orderliness. But look at the reflected beam. The reflected beam is scattered at all angles due to the nature of the surface, rough. Okay, so here no matter where you find yourself, you can have rays of light directed to where you are. Because the surface of the earth is not even, okay, that is why we could experience light from wherever we are. Even when our windows, yes, our buildings are opaque. But when you open your window, when there is a small aperture hole, light will still reach you due to irregular reflection of light. Please, are we okay? Are we fine?
Yes, please.
Another advantage of irregular reflection is that it brings about evenly distribution of the heat energy from the sun. So light energy is evenly distributed as well as heat energy from the sun. So these are the two main advantages of irregular reflection. A disadvantage is that there is no formation of image. Yes, the reflected rays will never converge or will never appear to have converged at a point. No, because of the fact that they are always scattered. But it brings about even distribution of the sun, or like even distribution of light from the sun, and even distribution of heat energy from the sun. Ask your questions if you have one. Hello.
I thought with the diffuse reflection, you see, even in the diagram, there's one point where none of the rays goes, like none of the rays it goes at all, like none of them go there.
Where?
So like I don't know, like if you could scroll up a bit. Here. You see, there's a side where none of the rays go there. So like over there'll be no light or something like that.
No, this is just a diagram. You see, the sun has a lot of rays coming, even a point source. When I light a candle, okay, it's an extended source. Once it's an extended source, it means we have a lot of rays coming from it. So what I've just drawn is just a diagram representation, okay? And I'm sure this is where you are talking about. Yes, once the source is an extended source, we can have light ray reaching this side. Okay, but this is just a picture representation. Mirabel, are you fine?
Okay. Yes, please. Thank you.
Welcome. Any more questions? All right. Then let's quickly look at formation of images in a plane mirror. Formation of images or characteristics of images formed in a plane mirror. So characteristics of images formed in a plane mirror. So when you see yourself or you look at yourself in a plane mirror, when you look at yourself in a plane mirror, How do you see your image in a mirror? Okay, like, how do you usually perceive the image formed, okay, within the plane mirror? Characteristics of images formed in a plane mirror. How is your image in the mirror usually like? Sanam, set the ball rolling for us.
Okay, so please, when you are looking into the mirror and let's say you raise your left hand in the mirror, it appears as if the right hand has been raised.
Okay, so yes,
But Mr. Dia,
yes.
Mr. Dia, does it apply to every mirror? Because there's this particular mirror. If you raise your left hand, to show that you have raised your left hand.
No, it applies to every mirror. I've had a chance to look at myself in some mirrors where my head is always so bigger than myself. Okay, yes. When it happens like that, then it's usually a defect with the mirror, manufacturing defect, because you cannot look at yourself in a mirror and then expect to see your head in a mirror bigger than your real self. Okay, so one, just as Sanam said, you look at yourself in the mirror. When you raise your right hand, it appears it is the left hand that is raised. Yes, when I go to the barbering salon, as the barber trims your hair down, when you look at the barber in the mirror, it always appears as if the barber is a lefty. But you turn and look at him, he's a righty. All right, so that is a true observation. We'll talk about that. Yes, what other observations have you noticed in looking at yourself in the mirror?
Like as in, if you stand like you don't stand directly in front of the mirror, you stand a bit away from it. It looks like the image inside the mirror is also a bit further off.
Okay, Mirabel.
I mean, when you hold a book in front of a mirror, the words inside the book seem to have turned around.
Okay, that's the same observation Sanam talked about. Abnaya, tell us about your mirror experience.
So please, the object is always the same as the image you get from the mirror.
Okay. Irene.
Yeah.
Give us your observation.
Please. On what?
Image, characteristics of image formed or images formed in a plane mirror. Or you don't use the mirror.
Please, I use it.
So tell us what you usually see when you look at yourself in the mirror. Okay, so you see the observation Mirabel, Sanam, and one other student here. You see, objects in the plane mirror are laterally inverted. So that is how to describe what you said, that you raise your right hand and it's always as if it's the left hand. Okay, you read a book, and it's always as if the book is turned this way. We call this as lateral inversion. Okay, this is my lateral side, so it's as if I'm turned this way. Lateral inversion. So we said that objects in plane mirror are laterally inverted. Objects in a plane mirror are laterally inverted. Please, are we fine? 2. Object distance is always equal to the image distance. So you look at the distance from you to the mirror and the mirror to your image the same. In the mirror, object size is always equal to the image size. So with a normal mirror, a mirror without any defects, the size of you and the size of your image, what you see within, are always the same. Image formed in a plane mirror is always upright. In JHS, you learned about the pinhole camera. And one profound observation in the images formed in a pinhole camera is that images formed in a pinhole camera is always inverted. Images formed in a camera usually is always inverted. The image formed on the retina of our eyes is always inverted. So if I look at you, Mirabel, okay, that your image that will be formed on my retina is always inverted, yet I see you upright. In a plane mirror, images are always upright. They are not inverted. Is that okay? And then?
Yeah.
Please, I have a question.
Okay.
So please, you mentioned that the image formed in the retina of the eyes is inverted.
Yes.
But then we still see people normal.
Yes, it's true. Yes, that normalization is done by your brain. Your brain gives you that normal situation. So the brain does the interpretation of what the information the retina gives to it. And your brain is programmed to see the image as upright, not what is captured on the retina. Is that okay?
And so please, why does the retina turn around?
Pardon?
Yeah, please, and why is it upside down in the retina in the first place if it's going to be right side up again?
Oh, that is the architecture of the eye. In fact, we have to ask God because, and I understand because of how we'll talk about optical instruments and we'll discuss this, why it appears inverted on the retina. Okay, you understand it better when we are looking at optical instruments. So for that explanation, you hold on. When we hello.
So you mean to say that we see everything upside down, but then our brain tends it
No, that is
upright.
what is captured on the retina? Okay, the retina is like the memory of the phone, the camera. What is actually captured on the retina is inverted, but the information is given to the brain to do interpretation of it, and the brain interprets it as upright. Are you fine?
Yes.
But on the retina, it is actually inverted as the image formed in a pinhole camera and all that. It is inverted, but the brain does the interpretation for us to see it as normal, upright. Is that okay?
Yes.
Then another important characteristics of images formed in a plane mirror is that images formed on a plane mirror are always virtual. So my small girls, one of them takes the mirror, looks at herself and tries to hold what she sees behind the mirror and it's well done. She captures nothing. Is that okay? You see something within the mirror, but when you take the mirror off, that thing is not there. Virtual. Images formed in a plane mirror are always virtual.
Yeah.
Hello.
Please, can you take a picture?
I will. I'll send a picture through the group. So images formed in a plane mirror are virtual. Virtual images cannot be formed on a screen, but real images can always be formed on a screen. Images formed in a pinhole camera are real, but the image formed by our eyes is real. It can be captured on the retina, but it's inverted. Okay, but the images formed by a plane mirror are always virtual, can never be captured on a screen. Are we fine?
Anastasia,
Hello.
is when you look at yourself in the mirror and you're holding a camera, you can take a picture of yourself in the mirror with the camera. And that one, like the image that is in the mirror has been formed on the screen. Oh,
Yes, with the camera, the image is always captured on a screen. So cameras would form a real image. But the image formed in a plane mirror is always not on a screen, virtual.
so Miss Jadia, what if the camera is the screen of the mirror? So the image is then formed on a screen.
The camera.
Like the camera has become the mirror.
Now, how can you do that? How can you do that? A camera has something special on which images can be captured, such as the film of the camera, which is outmoded. These days, it's obsolete. We don't use it. But now we have a chip, the memory. The memory captures the images. Okay. So the camera has this special feature but the mirror doesn't have this feature, right?
Carefully.
All right, so I think it's 9 o'clock already. I think let's I draw the curtain for today's meeting. And then we'll have, sorry we couldn't have it this morning, but I'll definitely make amends. But we have another session on Wednesday and Thursday. So good night and take care of yourself. Bye-bye.
Bye.
Okay.
Miss, please don't forget to take the picture.
I've done so, so I'm uploading straight away. All right. So I've sent it.